there's a large and growing videos. Okay, so a lot of videos there from our sessions, and I would suggest for those who haven't visited it that you might consider doing so. A lot of those important elements of discussion are captured. I'm not remembering to repeat all questions, but some of those are captured as well when I remember to repeat them. Please see if you can remind me. Okay, so for today, what are we doing? Well, we're going to be looking at mechanism or model output, pursuant to the question there. And that includes output to things like spreadsheets, output to files, output to databases, and collecting data from your model in general. Priesri will be giving us a guest lecture where she highlights three particular tools that are germane to this, specifically a tool that can dump a wide variety of information about things going on in your model automatically without you having to write any code for it. It will sort of take your model, instrument it in the appropriate way, and when it's run, it will actually dump out this huge volume of data, which could then be filtered and sorted, etc., in tools like Excel or put into a database. And so that's a tool which can give a lot of insight to exactly what's going on in your model and can allow you to zoom down to finer-grained levels through filtering if you're interested in knowing what's happening, say, to a particular person or what have you in your model. She is also going to be talking about a tool, and this is also germane to a question yesterday, which will output data collected in the model automatically to R for analysis in an external package. And as Kristen noted, once it's in R, it could be further provided for analysis in any number of different packages. Finally, in a nod to material that we'll be talking about later on best practices, there's a tool which will automatically record every time you run your model. It will record when it was run and how long it took to run, after it took place, and it will further capture a complete copy of the model and information on the parameter assumptions that were used for that run to allow you to reproduce that run, in the random number seed, to allow you to reproduce that run precisely if you ever need to do so in the future. Okay, and for those of us for whom simulation is a daily event, being able to go back and reproduce what we did 3 months earlier, 6 months earlier, particularly when that revise and resubmit request comes in, is very, very valuable. To have that precise model that we used on those days to make those runs that created those graphs we submitted to this prestigious journal. So it's an important component of Scientist Toolbox to have a lab notebook of sorts, and Priesri has created the much of the pages of a simulation lab notebook that can be used with any logic. So she'll be showing us her good work later this morning. Okay. Anyway, that's a little bit of stuff on output. Another major topic we'll be talking about is calibration. And I'll be giving a few words on performance and showing you a tool called a profiler, which can be used to run your model to understand where it's spending its time. Where is it bogging down? Where is it burning up lots of time? Because if you can identify those key bottlenecks, you can often go in and resolve them. And we'll see a little case where that's indeed the case. Okay. And we'll also learn a little bit about some of the other performance gotchas and have some tips for ways you can, for definite things you'll want to do to reduce the performance burden of your model. You'll want to have recourse to run your model more quickly on a regular basis. and another component that we'll be seeing, and I probably won't have time to spend much more than half an hour on this because of the strictures of the schedule, we're going to be talking about capturing interventions in this model. And this is an issue that I often leave less words on. How do you implement an intervention? Because so much of it can be captured by changing parameter values. We change our assumptions about the model. How likely it is that someone gets infected when they get exposed, or what have you. How likely is that someone regresses to diabetes after which is the use of dynamic parameters, and how you can use dynamic parameters to have very nice capturing of interventions in a way that different interventions select different subsets of people to change and can affect those people in different ways. So rather than hard-coding that into the model, you could specify that in an experiment and then just run it with the model. Okay, so you say, give me people of these characteristics as the subject for intervention. So in other words, these are the criteria for intervention. These are the things to do for those people who are intervened upon. Go off and do your work, and it will go off and do it. And you specify those in the experiment and not in the main model. So that's a powerful technique and one that's underappreciated in any logic. Okay, and then finally, as time allows, I'll be saying some words about best practices on the process side, things like use of peer review, continuous integration, use of pair modeling techniques to do modeling side by side. We're going to be talking about technical best practices a tiny bit, modeling frontiers, and then what I most want to provide you with before you leave is some resources for further study and sort of some summarization of places you can go for further learning. For those staying for the Java side, we'll be completing our discussion of functions and talking about subtyping and subclassing. What's this whole thing about a person being an agent? And why is it that sometimes agent is returned and I have to say, well, this agent is really a person. Just treat it like that, okay? We're going to be seeing where that comes up, and we'll be seeing why it's so valuable to be able to say to have this subtype hierarchy. Okay, so that's what we've got in the docket today. Any questions? Yes. Oh, yeah. Sure. I actually have slides on trade-off between modeling packages, and if there's interest, I could probably in about half an hour give some models, so I'd be glad to do that. Okay. Could you help remind me? Okay. That will be very helpful. I'll see if I could put this down. So these would be package trade-offs. Okay. Package trade-offs. We are a pluralist lab, and we have used all of NetLogo and Repast and AnyLogic and ModGen, and I've used SDML, although years back, in addition to a lot of work with Repast. And then also we use Vensim and continue to use Vensim a great deal. So I'll see if I can weave in some motivations as to why and when. Okay? Yeah. Those are good. Anything else? People want to say, I really, really, really would like this. Okay? The modeling frontiers, I'm going to be trying, if there's time available, I'm going to be trying to give a nod to what I think is a huge opportunity, which is this confluence of what's unfortunately called big data, digital epidemiology, or what have you, and models. I think there's huge potential here, and I think the landscape will be very different 10 years from now. So I'll try to give a nod as to why I think there's such potential there, and why I think models, far from being replaced by data-driven approaches, why they're going to become ever more central. Okay, great. Okay, good. So let's get started.